Welcome to program number 3 in the Electrical Test Equipment series. In this program, we shall discuss and demonstrate how to use and read mega ohm meters, also referred to as insulation testers. During the program, you will be given time to discuss with your course controller or perform practical exercises. In the overview program, you learnt that the megameter is used to measure resistances in the mega ohms range, and that the name mega is the common name applied to such an instrument. You also learnt that megas are high-range meters that incorporate a DC generator, which is either hand-motorized with a crank handle or electronically operated. The primary purpose of a mega is to enable the electrician to test the insulation of an electrical machine or an electrical installation and thereby ascertain if it is safe to use. Most, if not all, types of megameters also provide a low ohms function, used primarily to establish electrical continuity. Let's overview some important facts about electrical apparatus. Every piece of electrical equipment has two basic components, namely conductors, along or through which current must flow, and insulation, which prevents the flow of current. In certain equipment, for example an induction motor, many hundreds of turns of wire are looped to form a coil. Each coil loop is insulated to prevent short circuits occurring. Only with a megameter is it possible to assess whether the coil insulation is in good order by measuring the resistance between windings and to earth. Over a period of time, insulation material may break down as a result of aging or through periods of overheating. This may lead to potentially fatal conditions. Therefore, it is essential that any electrical device be tested periodically using a megameter. It is important that you understand the purpose of insulation. So let's use a simple analogy of water flowing in a pipe to help explain the concept of insulation. In a water system, a pump supplies the energy to force water under pressure along a pipe to its required destination. As water flows through the pipe, it is subjected to friction caused by A, the restricted diameter of the pipe, and B, by the roughness of the pipe walls, amongst other factors. If a leak should occur along the pipe, then water will escape and some of the pressure in the pipe will be lost. Likening an electrical circuit to the water system, the pump represents the energy source, for example, a generator or AC supply. The pipes represent the wiring. The thick pipe walls represent the insulation around the flow of electrons in the conductor. When a leak occurs in the insulation, then current will escape, resulting in a loss of pressure or voltage. A subsequent drop in the resistance to flow will also occur. Factors that affect the breakdown of insulation include moisture, heat, vibration, and corrosive vapors. A megameter is designed to effectively sense the condition of the insulation by sending a surge of high DC voltage through the conductor. Any voltage returning to the meter via earth is then interpreted by the meter mechanism in terms of resistance expressed in mega ohms. If there is a leakage or insulation breakdown, the meter will yield low figures, or less than specified, below an infinity reading. A typical check is to connect a mega between earth and one end of a motor coil or winding at its terminal point. A reading of infinity is considered ideal, reflecting absolutely no leakage. However, certain safety legislations allow any reading above 1 mega ohm, in the case of motors, to be considered safe. In the following demonstration, A motorized or hand-cranked megameter will be utilized. Preliminary meter tests should first be carried out. Connect both test leads into the instrument. Uncoil the leads and join the ends. Set the function switch to the ohm range. Then crank the handle rapidly. Observe the pointer, which should move across the zero mark. If the pointer does not reach zero, then the test leads are faulty and need renewing, or the meter's fuse has blown. Let's perform a typical insulation test, as normally conducted, on a new domestic circuit. The incoming line has been isolated and the main switch set to the off position. At the distribution board, we connect the common test lead to the earth block. The other test lead is connected to the neutral side of the main switch. Select a 500 volt meter range for a 220 volt circuit. Now perform a mega test and observe the reading. Next, we connect to the live side of the switch, and again a reading is taken. Finally, we check between neutral and live on the main switch. Readings obtained are noted and compared to the ruling regulation of SABS Code of Practice for the wiring of premises. The test we have just described is only one of many tests that requires the use of a mega ohm meter. After the break, we shall demonstrate a practical application for an electronic mega ohm meter.